Hey, Jack. How's everybody?
Good.
All right. Well, it's still a minute early. All right. A couple of things, logistical things. I'm going to just send you guys out a copy of the Excel spreadsheet that has your grades in it via email, since the Excel sheets seem to not be updating, even though I've deleted them and put them back in. So we'll do it that way instead. The other thing is, you should have gotten an email about the IDEA forms, which are your course evaluation forms for all of your courses here at Joule. I had scheduled the last day of class for you to do those in class. Obviously, there's no point in doing that now because you're not sitting in class. So you can fill those out whenever you want to. I would ask two things though. One, take them seriously, and two, if you wouldn't mind in the written comments, if you have any comments on how this whole adjustment to the coronavirus situation has been, good or bad, either way. You know, if there's something I could have done better, if things are going good, whatever it is that you want to comment on that, that would be especially useful. Right now, the college is making default plans for everybody being back on campus in the fall. But that, of course, is contingent upon what the condition is of the world that we live in. So any feedback that you have about what went well, what didn't go well, as we made this unexpected and quick shift to online ways of delivering instruction, that would be useful in the event that we do open school next fall, but to do it in a virtual way rather than in an in-person sort of way. So any feedback you can give would be appreciated, and it would help me as we plan for the fall. The assumption is that we'll all be back on campus, but that depends. And if we aren't back on campus, it would be nice to have some feedback from you guys as to how you thought this all went. Questions about those things? All right, then on slate for today is meeting systems. This PowerPoint is on Moodle, so you should be able to download that, and somewhere I should be able to share my screen. All right. So when we think about mating systems, the questions basically that are involved are, how do you go about acquiring a mate? How many mates do you ultimately have? And what are the associated patterns of parental care? We just got finished talking about parental care, and so this follows logically from what we were just talking about. So when you think of mating systems, you can think of monogamy, polygyny, polyandry, and promiscuity, as well as polygamy. So this is a table from your book. So if you have your book handy, you'll know what the answer to these questions. What do we mean when we think about monogamy?
One male and one female stick together.
Yes, one male, one female, and it's generally thought of as an exclusive arrangement. But this exclusive arrangement can be exclusive for a particular breeding season, or in the case of things like albatrosses, it can be a lifelong pair bond. When it's just for a breeding season, so you have one male with one female for this breeding season, and the next breeding season you may have that male with a different female. That's referred to as serial monogamy, but for that reproductive effort, there is no extra pair mating, and so that would be monogamous. Oftentimes in monogamy, both parents care for the eggs and young. What would polygyny be?
Males having multiple females.
Males with multiple females, and this can take on a wide variety of forms, and this is fairly common. In this case, in many cases, the female provides most or all of the parental care. Polyandry is, of course,
The reverse.
the reverse, one female with many males. This is one of the most unusual situations, and we've talked about all the reasons why this would be unusual. And in this case, it's flipped such that the male generally provides most or all of the parental care. Promiscuity. And this is an animal behavior promiscuity, not a promiscuity as you would apply the term to humans. This is just a description of who mates with whom.
Isn't it just everybody's going for everybody?
Just everybody going for everybody. Males and females may both have multiple partners during a breeding season. And then what is polygamy?
It's like lions, right? Is that an example?
No.
No.
Lions would be an example of polygyny.
Hmm. I mean, I watch Sister Wives, so I assume it's something like that.
Well, Sister Wives, I've never seen it, but I've heard about it on NPR because it was popular with the NPR listening public for whatever reason. But that's actually not, it is polygamy, but it's more specifically what?
Polyandry?
Not polyandry. Sister Wives, plural.
Polygyny.
It's polygyny, isn't it? So polygamy or polygamy is just a general term for when individuals of either sex have more than one mate. So it's peculiar, this discussion that we just had. As humans, we generally think of polygamy as what?
Marrying multiple people, or
But it's almost always who marrying whom.
a male with multiple wives.
It's almost always males with multiple wives. What was the name of that the show? It was Big Love or something like that, right?
Sister Wives.
Oh, was it Sister Wives? Okay. Anyway, when we use this term, polygamy, as humans, in virtually every case in humans, we call it polygamy, and it is one male with many females, but it could just as easily be one female with many males. Because this term refers to both of these things. Yet when we use it to describe human mating systems, this doesn't really happen very often. And so we use this general term to describe this particular situation, which is polygyny. And I just want to put this in front of you because it highlights the way in which we use language. We can use gendered language in all sorts of ways. If you're the first person to think of an idea what term do we use to describe that idea?
Novel?
Okay, we can use novel, but oftentimes we use a different word. It's this person's blank idea. Or maybe you guys don't use this term at all. I actually heard somebody in a faculty meeting use this term, and I had to stop myself from calling out their use of gendered language. And strangely, it was a woman who used the term. You ever hear of somebody having a seminal idea or a seminal contribution or a seminal work of some type? You've never heard this term? Have you heard this term? Nope.
I've heard it, but not often.
Oh, really? Oh, well, anyway, somebody in a department meeting talked about something and described it as a seminal idea. And I was like, wow, that's really gendered language, because it has to do with who's doing the fertilizing of a particular field when one has a seminal idea. And so it's basically referring to the male gamete that is fertilizing an entire field of thought with a particular idea. We use the term polygamy or polygamy because as humans, we probably want to avoid calling attention to that in all cases of polygamy, with one exception that I know of that occurs in Nepal, in all cases of polygamy, it's actually dudes with more than one female, which is technically polygyny. But polygyny calls specific attention to the fact that it's the dude with multiple women rather than women with multiple men. We should call it what it is. It is polygyny in most cases. And strangely enough, we don't use that term because we live in a male-dominated society, and males decide what language gets used, is more than likely the case. It's not that people don't know that these other words exist. It's that we have chosen to not use the appropriate terminology. So throughout this discussion, when you speak of male individuals with multiple females, it's polygyny. When you speak of females with multiple males, it's polyandry. I'm not actually going to use the term polygamy because it's overly general and doesn't actually describe the specific case that you might be using. So much gendered language in our lives when you start thinking of what the roots of words are that we use. Anyway, that's my own pet peeve about polygamy. So, in many cases, in most cases, males do not provide parental care. So when we think about the mating system that might come about, we can actually think about the distribution of females. And female distribution is going to be influenced by the dispersion of resources. Resources can either be concentrated spatially or they can be dispersed. We can also think about what the distribution of predation is and what the risk of predation is. Is risk of predation high or is risk of predation very low? And then we can think about the benefits and costs of living socially. Taking these three things, which are all things that we've talked about recently, we talked about predation, we talked about resource dispersion when we talked about competition, and we talked about the benefits and costs of social living in the section on living in groups. And these three things will influence how females are dispersed in space. And then the female dispersion pattern will generally dictate what the male dispersion pattern has to be. And so one way of thinking about this is males generally will respond to female spacing patterns in terms of how they go about trying to gain access to mates. In many cases, female dispersion is going to be influenced most heavily by resource dispersion, to a lesser degree by these other two things, such that males can either respond directly to female dispersion that might be driven by resource dispersion, or they may respond to resource dispersion directly. If you control the resource that a female needs to reproduce, that will then attract females to you because you are a possessor of whatever those resources are. So two ways of thinking about this: males responding directly to female dispersion, which is influenced by these other three things, or males responding to resource dispersion, which then affects where females are dispersed. Either way you look at it, and it will vary depending on the specifics of any individual case. Once again, males are basically trying to place themselves in the presence of females, whether they're responding to females directly or controlling resources that females need for reproduction. Layer on top of all of this, don't forget that the relative advantages, generally speaking, to males and females in terms of what enhances fitness, remember that those things are different. Females generally benefit more in terms of fitness gains from increases in parental care provided by the male. Males tend to increase fitness by mating with as many females as possible. So that's just something that should always be in the back of your mind as you think about these things. So when we think about female dispersal, you can think about resources that are widely distributed versus resources that are distributed in clumps. Under these conditions, it's difficult for males to control access to the resource. As a result, you should not expect polygyny to evolve or polyandry to evolve, either one. And in a patchy distribution, you should expect polygamy to have higher potential, because a male or a female, but usually a male, has the ability to control access to a resource. So through interference, competition can keep other individuals away, and that resource will be attractive to multiple mates, and you can control access to it because it's clumped in nature. So when we think of these things, we can kind of make a flow chart. And this is, the first time that I covered this material in this book, I thought to myself, well, what's a better way for students to kind of organize these ideas? So you can start with resources as being kind of the primary thing. Are resources dispersed, or are they clumped? Then within these dispersed and clumped resources, you can ask yourself, what's the level of predation? Is it high predation or is it low predation? And then the third thing is the cost to benefit ratio of living in a group. Is it greater than 1, meaning that the cost is greater than the benefit, or is it less than 1, meaning that the benefit is greater than the cost? Anytime you have a low cost to benefit ratio of living in a group, anytime that ratio is low, you're going to be pushed towards living in groups rather than living by yourself. Anytime the cost to benefit ratio is high, greater than 1, you should expect individuals to avoid groups rather than living with groups. So the upper half of each of these things would tend to push you towards solitary living, and the cost to benefit ratio less than 1 will tend to push you towards living in groups. And so these things are the things that influence female dispersion. So the question that you have to ask of yourself is, for each of these situations, what is going to be the effect of these three things on female dispersion? Will females tend to be solitary, or will females tend to be social, live in social groupings? That then will tell you what the males are going to do to a certain degree. So when we look at dispersed resources with high levels of predation, where the cost to benefit ratio of living in a group is high, there's really no reason to be social. If predation rate is high, chances are groups of individuals are going to attract predation. The costs of living in a group are high because it reduces your access to resources, and those resources are dispersed such that males aren't going to be able to control the resource, neither are you. There's zero benefit to living in a group, and so you should expect females to be solitary under these conditions. If resources are dispersed and predation is high, but the benefit of living in a group is high, then you might expect some sociality to occur. But because of these other two aspects, dispersal of the resource and high predation rate, you might see a certain amount of solitary living. And so in the cases in this thing, you're going to see situations where both things are possible, but one is more likely. In this case, the one is more likely because of the benefits of living in a group. The benefits of living in a group might be benefits that either help you gather more food or help you with increased vigilance that helps you with predation sort of situation. If resources are dispersed, predation is low, but once again, the cost-benefit ratio of living together is high. Then once again, you might be social, but more than likely you're going to be solitary. And then if predation is low and the cost to benefit ratio is less than 1, meaning that it's beneficial to be in a group, then you should of course expect what? Anyone? Social. Yeah, you should expect, oh, I don't know why that's not highlighted. You should expect social, things moving more towards social rather than solitary. And that social should be bolded. If resources are clumped, what should that tend to push you towards? If resources are aggregated in space, everybody's going to have to go to that particular place. So what should you expect to come out of this? Social. Yeah, you should expect some movement towards sociality in spite of the fact that there's a high rate of predation and the costs of being social are high. You should expect social, even though you might see some solitary living. And once again, this clumped resources is going to influence the situation, even when the benefit increases of living in a group, that will once again push you towards sociality as well. Under situations of low predation, once again, the clumped nature of the resource is also going to push you more towards social situations. And this is one of the this is another thing where the social should be bolded. I don't know why those things are not bolded, because I could have sworn that they used to be. And so when you think about this, you can say, not with 100% predictability, but with a certain degree of skew, that under certain types of conditions, you should tend to see organisms being more solitary, and under other conditions, you should tend to see them being more social. And actually, well, I can't change it easily because it's all covered with things. I'll fix that and update the slides. So one of the things that you'll notice is that one of the primary drivers of this is the clumping or not of resources, with these other two things having less of an influence on what you should expect. So when we think of female dispersal, one of the questions in the mind of a male is, how defensible is the female dispersion pattern as a potential resource to take advantage of? And so whenever females are solitary, they're defensible by the male. And the reason that they're defensible by the male is because there's only one of them there. And you're not going to run across another female anytime soon. And so if females have small ranges, you might be able to have males who can control the range of a number of different females. So if females are living solitary lives, each one has a range of activity. Oh, not male, female symbol. Each one of these has a range of activity, but they are not living in a group, and that their territories don't overlap with one another. You may have one male who is able to control all of those females if those females' ranges are small. If, on the other hand, because resources are really dispersed, you have females that are occupying large ranges in a solitary situation, it might be very difficult for a male to control access to females in this situation. So the range size that a female occupies might influence whether you would tend towards polygyny or not. If you have ranges that are large, you might actually just have males hooking up with females, controlling access within that female's range, but not being able to defend multiple female territories. And as a result, you have monogamy resulting. So once again, this dispersal pattern is mainly being driven by the dispersal of resources. The more dispersed, the larger the female range is going to be, the harder it's going to be for the male to defend that range. And as a result, you tend towards monogamy. If you have females that are solitary, but the range is really not defensible by the male at all, meaning that the range is so large that the male can't even control access to one female, what you will see is you'll see polygyny, but it's a different kind of polygyny. It's not a polygyny that is based on defense. It is a polygyny that is based on males being wide-ranging, females being wide-ranging, males and females come into contact with one another, and if the female is in estrus, the male will mate with her. If she's not, he won't. And in this way, he might end up mating with multiple females, but not because he has exclusive access to any of those females. Any other male could have mated with that female as well. And so this is a defenseless sort of form of polygyny. If females are social, they're occurring in social groupings, they're definitely defensible by a male. In this case, you might have permanent harems. This is one of the things that happens in elk. Here in North America, oftentimes you will see a group of female elk with one dominant male elk, and they will travel around with that male, and that male will have exclusive breeding access to those females. That situation is referred to as a harem. And those can be permanent or semi-permanent, but in this case, the book refers to this as a permanent harem. Defended by a single male, or in some cases related males, and it all depends upon the size of the female social group. If social groups are small and can be defended by a single male, then that would be the case. Females can be social, but they might range over a range that is not defensible by the male, in which case this is going to be dependent upon female movement patterns. So you have a group of females that are hanging out in a group. If they're ranging over a large area, the male can't control access to that group. And so oftentimes what males will do is they will station themselves at positions where they know that these groups of females are going to be coming around. And so if movement patterns of females are predictable, males can basically station themselves to intercept these groups of females and mate with them as they're kind of coming through. So if the movement pattern is predictable, the males do the stationing situation, and this sets up the possibility for male competition for these sides. And so if there's a predictable movement of females, males will position themselves at the places where the females will be coming by. And if that's known and predictable, then you might have multiple males showing up, competing for access to that resource, which is merely the resource of the place where the females come to. And then you'll see male-male competition occurring.
I have a question.
Yep.
Why don't the males just like stick with the like in the case of the elk? Why doesn't one male just find himself a group of females, and even if they range for a long, a large distance?
Well, that is what happens with elk in this case. They do stick together and they range around together, because generally herds of elk are small enough that they're defensible by a male. So if females are sociable and they're defensible, then you can have these harems developing. If it's not defensible by males, either because the females are too large of a group, could be one of the issues, or they range around so broadly that the male, for whatever reason, isn't going to follow the females, then he's not going to stick around and mate with them. If once again, remember what is in a male's mind evolutionarily. So one of the problems with elk is that they tend to range on mountains, and they tend to range, they tend to follow forage. And so one of the things that happened after they put wolves back into Yellowstone is these elk that had been foraging down along riverbanks for a long time, decades, because of the loss of wolves. When the wolves came back, they basically didn't kill and eat a lot of elk, but they changed the elk movement patterns such that the elk went back up into the mountains, which is where they traditionally live, and they didn't come down into the river bottoms, and they didn't feed on the trees very much anymore. So kind of the pre-removal of the wolf-elk pattern is to basically spend their time up in mountain meadows foraging on grasses, and when they came down to the lowlands, they tended to browse more on young trees, and as a result, they basically wiped out all of the riparian forest that used to be in Yellowstone. And so traditionally, elk would be in these meadows, moving from one meadow to another as they grazed different meadows out. They would move to a fresh meadow. They didn't tend to come down to the rivers in the river bottoms, and as a result, their movements were not particularly predictable. And so what a male would do is latch on to a group of females and travel around with them. And then he knows that he has access to those females when they come into estrus. Not a good strategy for him to position himself at something like a river where all of the elk are going to be coming down to drink or something like that. And so elk maintain harems because they're widely dispersed, they move around, their movements are not random, and it's better for them, for the male, to hang out with a group of females rather than station himself at a place. If you have a group of females and they're wandering randomly around the environment without any sort of predictable situation, it's difficult for a male to station himself someplace and hope the females come by. So what you want to do, attach yourself to that group of females, travel with them, defend them if they're not too big from other males, and then you have exclusive access to that group. If, on the other hand, the movement of the females is predictable because they all come to the pond, this is a river that then has a beaver dam on it or something, and it widens out into a pond, and all of the females come predictably to this place to water, then a male can station himself here, take advantage of these females when they come by. But if there's another group of females who are also going to come to the same pond, it's way better for him to just station himself in that place, wait for the females to come by because they have these predictable movement patterns. And now he has access to access to 15 females, whereas he would only have access to 9 females if he was maintaining a harem. Does that make sense?
Yeah, that makes sense.
What's that?
Yes.
Okay. All right. So In unpredictable situations, you will oftentimes have synchronous estrus, where all the females come into estrus at the same time. These things are seasonal harems, and so actually, this is actually the elk thing. I just saw this when I was at Rocky Mountain National Park last year. I saw a bunch of social groupings of females that were without a male, and I saw a number of male elk that were actually just wandering around by themselves. So my apology about the elk analogy. The elk is more of a seasonal harem sort of situation because all the females do come into estrus at the same time. And had I thought about my experience in Rocky Mountain National Park last year, I would have remembered that. Asynchronous, males roam around and mate with females as they come into estrus. But once again, they're going to be moving around basically with a permanent group. And as the females come into estrus, they'll mate with whichever ones happen to be in reproductive condition at the time. So there are some examples in your book looking at polygyny. The gray-sided voles are an animal where there is aggregated food distribution, so the food occurs in clumps. Females have small female ranges, and this then affects the male dispersion pattern. Because males follow females, the males may be following females, or they may be honing in on the resource distribution. And so what they basically did was they caged females to control spacing patterns and then tracked male movements. And what they found is what was predicted from earlier in this whole thing. If we go back to this, no, not this diagram. I went too far back. To this diagram, you can either have males responding to the resource distribution, or you can have males responding to the distribution of females. In this case, what they found by experimentally controlling the distribution or the dispersion of females, they basically found that the males were not responding to the food aggregations. They were actually showing that males were responding to the distribution of females that were independently manipulated from the food dispersion. And so in many cases, males are actually tracking female dispersion patterns. And there's a fish species that's also used in your book as an example, where this basic same finding was verified. The majority of species have solitary females. Females, though, can also be social, and males usually mate with female and then desert the offspring in polygynous situations. Only about 3% of species have males that defend the young or feed them, and so any parental care given by males in polygyny is relatively rare. And so polygyny involves male mating with multiple females and contributing hardly any parental care. Now, there is a special and fascinating situation which involves leks and choruses. And the reason that leks and choruses are fascinating and interesting to behavioral ecologists is that leks and choruses in many cases seem to have no resources of value to the female. And this has perplexed individuals who have looked at this for literally decades. So in a lek or a chorus, presumably there are no resources that are defended, although in many cases, as we look more carefully at this, we find that there is spatial variation that is being defended, but there's still plenty of situations where we can't or haven't yet found what might be of interest to females. Have you guys ever been out to view prairie chickens doing their thing?
Never.
What's their thing? Doing their lekking in the spring. Male prairie chickens will descend upon a plot of land, and they will all compete with one another for basically access to what are prime spots in the lek. But when you look at the lek just looks like a patch of prairie. I've seen this a couple of times now in the Flint Hills. There are places on Konza. So every spring, Konza Prairie has prairie chicken booming stands set up where you go out there early in the morning, you get in a blind, a bird blind, and it has little windows, and then as dawn comes, the prairie chickens start their displays, and it's pretty cool. Can you guys see this video on my computer screen? Okay. Can you hear the audio? No. Okay. So this is a prairie chicken male, and they make this weird noise. When they inflate their pouches, they go woo 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 woo. Wings are down, tail is up. These feathers that look like horns can be draped over the neck, or they can be erect like that, and then they inflate these big pouches on either side. These are two males now coming into contact with one another. This is a subordinate male. His feathers on his neck are down, and he's about to be harassed by this dominant male. Lots of chirping and booming going on. They make this really haunting, hooting noise. Stamping his feet, dragging his feathers, inflating his air pouches. Gonna charge, gonna charge, gonna charge. Chasing him out of his territory, chasing that other male out of his territory successfully. That male back there was maintaining a territory. The challenger on the left is trying to get that dominant male on the right to get out of there, but that dominant male is not giving up his spot on the left. And that's like a sportscaster. Now we got two fairly dominant males about to go at one another. Oh, one of them is backing down. I literally have sat in a blind for like 4 hours at a time watching these birds do this. It's actually funner if you can hear the noises. Oh, here comes the challenger in from the left. Gonna chase that dude away. Terrible camera work. There's no bird there. It's over there. Yeah, it's there. There it is. That's that same male that we saw a few minutes ago who is in full-on display mode. And really hasn't let up the entire time that this video has been going on, which is like 3 minutes and 20 seconds so far. Anyway, there's a link. The link is in the PowerPoint, and you can go and watch this yourself, and you should, because it's actually better with the sound. So what happens at these leks is these males all show up at a particular spot, and it changes from year to year, and they kind of station themselves in space. And so there will be a male here, there will be a male here, a male here. Male territories are set up, and they're defended by these males charging one another, displaying their feathers at one another, things like this. And usually there is one central male that happens to be the male that gets all of the matings. So I'll just describe him here. And the weird thing is if you go into a lek and you kill this male and get him out of there, and they've done this back in the past when it was okay to kill prairie chickens as part of your research, you can't do that anymore. But when they remove this male, there will be a jockeying a jockeying for position among the males that remain, and one male will move into this spot, and perhaps this male will move into that spot. And as a result, this area of the lek will no longer be occupied, and that male will once again be the one that gets most of the matings. And so even though this territory doesn't look any different than any of these other territories in terms of the resources that are there, it's basically just a bunch of grass and forbs. The male that occupies whatever that prize position is the one that gets most of the matings. And it's a really skewed ratio of the number of matings. We'll look at that in a minute. And what happens is the females will arrive at the lek, they will kind of check out the males, and then the females will choose to mate with whatever male that they want to mate with. And then they leave the lek, they go off into the prairie by themselves, and then they lay their eggs and raise their young on their own. And so presumably the females aren't getting really anything out of the male except fertilization services. And so one of the things that has always perplexed behavioral ecologists is, why do males lek? Why do they gather together in these groups? And what exactly is it that females are queuing in on such that all of the females tend to mate with only a few of the males in the lek? Because presumably there's no resources. So some explanations for this is that if females are widely dispersed, population sizes of the organisms might actually make male-male competition too costly. And so when you can't defend the males, so what happens during the rest of the year is all these prairie chickens, both males and females, are just scattered all over the prairie. The males aggregate at these places in the spring, the females come to the males. There's male-male competition at that place, but after breeding is over with, they'll just go their own ways, and you only have to defend your position for that small period of time when mating actually occurs. And this is a widely dispersed area, and one of the problems of the prairie chicken in terms of its viability is that in many cases, these lekking sites have been affected by things like agriculture over time. So in leks, if you look at the lek in terms of the rank order of success, you have one individual who, in this case, is getting about 35% of the copulations in Uganda and Cobb, and everybody else is considerably lower than that. The white-bearded manakin, the dominant male on a lek, is getting greater than 70% of all of the matings. And in the case of sage grouse, which is a species that is related to the prairie chickens, once again, you get almost 50% of the copulations are being achieved by the dominant male, with a fall-off, a fairly precipitous fall-off for the lower-ranking males. And so in these leks, you have one individual typically that gets the most matings, and the remainder of the copulations are spread across the subordinate males. But there are always plenty of males who aren't getting any copulations out of the deal. So the question is, why do males aggregate? It may be that males go to places where female encounter rate is high, so there may be hot spots. Once again, stationing yourself near a resource that the females need, and that resource attracts a bunch of males. But when we look at these leks, we find that there aren't any resources there that are available anywhere else. And so it must be a hotspot for some other reason. Perhaps it's on a female migration path or something like that. Males may aggregate to reduce predation, although this is probably not the case with prairie chickens, because I was in the blind one year, and I think I told you guys about this before, where we've been in the blind for an hour and a half, and all of a sudden there's this huge ruckus that is occurring behind the blind, and evidently a hawk swooped down, grabbed a prairie chicken, grabbed it off the ground, brought it up on top of the blind where we were stationed, and proceeded to kill and eat it right above our heads. And when we emerged from the blind some hours later, next to the blind was the remains of this prairie chicken that had been killed while we were inside the blind, viewing the other living prairie chickens doing their thing. So, but in some cases, these aggregations actually do reduce predation. So in the case of prairie chickens, all that noise that they're making may actually attract predators, whereas in the Tungara frog, Physalimos pustulosus, it evidently reduces predation. So Physalimos pustulosus is this fascinating frog that some of you have become familiar with because you mentioned it in your literature reviews. This is a species that happens to be hunted by a frog-eating bat. The bat hones in on the call of the frogs and will swoop down onto the surface of the water and pick off individual frogs and then kill them and eat them. As the chorus size increases, the predation risk for any individual frog goes down. This is a classic kind of dilution effect, but also as chorus size increases, the number of females that are attracted to that chorus also increases. And so in this case, males may be going to hot spots where encounter rate with females is higher, but it also may serve to reduce predation. Keep in mind why males aggregate. The reasons may not be exclusive of one another. They may actually be complementary to one another, and that certainly seems to be the case with Tungara frogs. Males aggregate to attract females. This is a concept known as stimulus pooling. A single frog out there calling in the darkness may not be loud enough, may not create a stimulus that is loud enough to reach wide-ranging females and attract them into the pond. But if you get 300 of your friends and or competitors all calling at once, you can create a large enough stimulus that it can be heard at a distance, and that will attract females in. Unfortunately, you can't hear the video of this, but if you click on this link, it will take you to a YouTube video, and the YouTube video focuses on a single frog. But the reason I chose this video is that in the background of this single frog, that's actually quite loud, you can actually hear lots of spade-foot toads chorusing at this chorus at the State Botanical Garden of Georgia. The other thing you might want to look at while you view this video is look at the body contortions that this animal goes through as he is calling. Frog calling is a very energetically expensive activity, and so there's significant cost in terms of energy to engage in a frog chorus. Anyway, go listen to that video and you'll hear all these other frogs in addition to that one calling, and it can be quite loud. When I was in graduate school, we used to go to this upland marsh that was near the campus. It was about 7 miles outside of town during the springtime, because lots of frogs and salamanders came to this pond to mate. And when the frogs were in full chorus, we would spend 3 or 4 hours out there collecting frogs and salamanders, and I would get home and I would have this splitting headache just from the noise I had been subjected to. It was like going to a rock concert. So stimulus pooling actually can be very effective at attracting females. Another reason that organisms may let in chorus is because males may aggregate around an attractive hot shot. So if one male is particularly attractive, that male itself may attract other males because those other males know that that male is going to attract females. Once again, males responding to the probability of female appearance, the appearance of females, the act of females coming around. All of these are possible explanations as to why males aggregate. Another reason might be that females prefer male aggregations because it facilitates mate choice. And so if you're in a wide-ranging species, it's hard to compare males to one another. As a result, females may be attracted to male aggregations because it offers them the opportunity to make direct comparisons. So in mating systems with parental care, we have, of course, monogamy. Monogamy, in most cases, results in both parents caring for the offspring, in many cases because biparental care is necessary for brood success. If one of the parents defects, deserts, you end up with an unsuccessful mating attempt. And we see some organisms that have relatively long pair bonds. And when we see these relatively long pair bonds, once again, scientists are interested in explaining why pairs of individuals would stay together for longer than one breeding season. And so I think this is the dunnock. Is it the dunnock? What we see is that, no, this is an oyster catcher, sorry. It's an oyster catcher. What we see is when we look at the duration of the pair bond in years and the egg survival, we see that egg survival peaks out here at a pair bond of about 7 to 8 years. And so the longer you are together with a single partner, your success increases until you finally start to age out and your egg survival begins to decline somewhat. So one of the reasons that you may stick around with the same individual year after year after year is that the longer you are together, the more successfully you are at protecting eggs, and also the more successful you are at fledging offspring. You see once again that the peak here occurs around year 6 for fledgling production. So when we think about monogamy, there's always the possibility that monogamy will break down. This figure basically shows 2 territories. This is once again a figure from your book. Shows 2 territories. This is a situation where a female leaves one territory and goes to another territory, and as a result is breaking monogamy. In panel B, you have an outside female essentially kicking out a resident female from that territory and taking over the territory here. So in this case, this then becomes a polygynous male. This is a monogamous male who no longer has a partner, and a monogamous male who now has a new partner. In this case, this female is actually polyandrous. But what we find typically is that females that initiate divorce, in this case breaking up the monogamous relationship, when females initiate it by leaving, they generally are leaving for a better territory, and as a result, they generally improve their reproductive success. So this female is leaving because this sad male has a sad territory and is going to a male with a better quality territory, and as a result, raises more offspring. In the situation where females get displaced from a territory by another female, they get booted out basically. After they get displaced, they generally suffer reduced reproductive success. So in both of these cases, this female here and this female here are both the initiators of the breaking up of a monogamous relationship. And in both of these cases, it's the initiator of this breakup that benefits, while the victim of the breakup generally does not. And so in this case, this male is the victim, and he is receiving less reproductive success because he no longer has a female. And this female is the victim. She's been booted out, and she receives lower fitness gains because she no longer is associated with the male. And this male is neutral to the whole action. He either has a
female to mate with her, or he has a female to mate with her. It doesn't really matter to him. But this is the situation that happens with oyster catchers when the monogamous relationship does break up. So you may be monogamous for a variety of reasons. And one of the reasons that you may be monogamous is because you just don't have the opportunity to be polygynous. So the reasons for this might be that if there's strong male-male competition, it may be difficult to find a second mate. And females may suffer from polygyny because females may be hostile to one another. And as a result, females may enforce a certain amount of monogamy by basically being hostile to other females that might want to be in a polygynous relationship with a particular male. Any questions about all this so far? You guys have been amazingly quiet today.
So far, so good.
Everybody hanging?
Yep.
Okay.
Yep.
All right. Let's talk about paternity testing. Paternity testing, I used to do this for a living, strangely enough, but we can also do this with organisms. And it's only when people started doing paternity testing of animals in animal behavior systems that we began to see how monogamy on the surface oftentimes isn't monogamy. So this is a figure from your textbook. Trying to remember, I didn't put the species up here. Oh, these are mongoose. So here you have male A, here you have male B, here's the female, and here's a bunch of offspring from this female. And what paternity testing basically does is it looks at, in this case, microsatellite markers, and it basically says what microsatellite markers does male A have, what microsatellite markers does male B have, what satellite markers does the female have. In this case, the male A and female share this microsatellite. And so all of these individuals are clearly the product of the mother, but you can't distinguish whether this band is in the offspring because of the mother alone or a combination of the mother and father A. But what you do see is that parent, the male A, is responsible for offspring 1 and 2, and male B is responsible for offspring 5. And so it may very well be that male A is also responsible for offspring 2, 4, 6, and 7 because it's polymorphic. It's a heterozygote for 2 different microsatellites. So you're at the same microsatellite locus, and one of these has more repeats than the other. So a microsatellite is just a tandem repeat. In this case, it's a bunch of guanine thymine repeats, as I recall. And so you have to run these on polyacrylamide gels. So you need a special gel in order to do this, because what you're doing is you're separating really small fragments of DNA from one another. And so you have a random repeat. 1, 2, 3, 4, 5 repeats versus 3 repeats. The shorter fragment travels further down a lane than the larger fragment, and so as a result, you can separate these fragments. You have 2 copies of your DNA, one that you received from your mother, one that you received from your father. In the case of father A here, one parent had 5 repeats, the other parent had 3 repeats, so he's heterozygous for this microsatellite. Individual B may have had 7 repeats, and the female has 5 repeats or whatever it is. You would have this calibrated by some sizing ladder that's not shown here. And so presumably, assuming that this female only had access to male A and B, male B is the father of individual 5, and male A is the father of all of the rest. because 1 and 3 have the smaller microsatellite repeat, and presumably all the rest of the offspring have both the mother's copy of that microsatellite as well as the father's copy of that microsatellite. So you can use this to then look at the frequency of extra pair matings. So when you look at red-winged blackbirds here in North America, what you see is that there is a surprising amount of extra pair fertilization going on. And so in the red circles, this is once again a figure from your book, you see that the majority of males are experiencing some level of the majority of females rather are experiencing some degree of extra pair fertilizations. And the directions of the extra pair fertilization are shown by the arrows. And so you can actually see which males are fertilizing the eggs from other females. And so in many cases, these are individuals that are moving to adjacent territories to get extra pair matings. So monogamy is not necessarily as monogamous as it appears. And we'll pick up here on Friday, I guess it is. Yes, Friday is coming up. Questions?
I just have kind of a general question about class, but then I have a personal question for afterwards.
Okay.
Generally for class, since we're like kind of approaching the end here,
Yes.
I know there's still like 4 written grades that need to come out. Can we still make corrections even if it's finals week by the time we get those? Or...
Yes, I am working on grading those right now. As soon as I have them graded, I'll get back to them too. I should have them back to you next week. And so, yes, the same thing applies. One of the things that they've done is they've put off the deadline for when we have to have grades submitted. And so we have until Wednesday the 20th, I think, to submit grades. So my goal is to get your written assignments that you've turned in now handed back to you early next week, so you have plenty of time to make any corrections that you need to. Once again, keep in mind that the only corrections that you need to make are corrections that resulted in a pass and or fail, a fail rather than a pass. You don't have to revise the whole damn thing. You just have to fix those things that were problematic.
Okay, sounds good.
And I think most of the people who have needed to make those corrections, they weren't too difficult to make because it was very focused on what needed to be fixed. Then you can talk to your peers if you want to hear about their experiences.
Okay, yeah, and then I just have a question just for you. So
okay, then anybody else have any questions? All right, I'm going to turn off the recording and then I will talk to Alexis and I will see the rest of you on Friday.